surprise, but it certainly helps, I believe, set the stage. So the first one is, of course, data growth. We're seeing the scale significantly increase, and in fact, in the 5 years leading up to the end of this year, Gartner is estimating 800% growth in the amount of data. So with that comes the requirement of storing that data, protecting that data, and making sure it's available. When it comes to the application level, so what IT is hearing from their application owners, they're of course hearing about performance. My application needs performance, and being able to take all this data that they're getting, understand which data needs higher performance and which data can get by with lower performance, and then also handle the scale. We're certainly seeing that performance can create a competitive advantage based on given applications, the core applications for a workload. And companies or IT is really looking for how to give those applications performance, but also deal with the scale and cost-effectively store the rest of the data. And then finally, operational disruptions. As the chase for the lowest dollar per gig and cost savings continues to drive IT decisions, first and foremost, operational uptime will always be paramount, will always be a high priority. The data has to be available, has to be up, or else it's worthless. And then, of course, do all this with a flat or declining IT budget. And this is really the big challenge, is bringing all these things together. The growth in data, dealing with performance and scale, making sure it stays up, and then do so with limited budgets. So the exciting news is that Flash can really help with all of this. So with Flash, we can deliver higher application performance and, maybe more importantly, even delivering performance at scale. And then Flash also enables us to reduce costs. And we're going to talk about that here in a second. But the key is there's not a one-size-fits-all solution. Certainly lots of buzz in the markets today around Flash, lots of FUD in the marketplace today around Flash of, trying to replace all disk with Flash. That doesn't make sense. Trying to always get by with a hybrid solution, that doesn't really make sense either. It's really about looking for which size fits my solution and my application based on my requirements today. So we're going to look at this from a couple different perspectives. So the first is that the right solution is always going to balance performance and capacity. And everybody should recognize this chart. This is what we lived with for a lot of years with traditional hard drives, is this very linear line of scaling performance with capacity. And if you had high performance requirements and low capacity requirements, you were forced to over-provision your storage. So deploy these partially filled disks in order to get enough drives in place so that you could get a lot of performance. The exciting thing is that Flash has really changed the slope of this curve. So now if we look at traditional storage with Flash acceleration or hybrid storage, we're able to cover a great deal of this picture, and really helps us get into service level objectives and service level agreements in the most cost-effective manner. So now we can dial in the performance that we need and only pay for the capacity we need. So we're not having to over-provision that storage capacity any further. But then we still have this, this area up in the top left where we're really pushing extreme performance, and we typically have very modest or small capacity requirements. And in a lot of ways, this is the space that's really being filled in with all Flash, really kind of completing this picture of enabling now IT organizations and customers to have lots of options now to really get exactly the performance and exactly the capacity they need. So if we look at how this plays out from a dollar perspective, traditional hard drives are always going to deliver the best dollar per gigabyte. With the price of Flash dropping, the performance gains you get from Flash are finally outweighing the cost, the additional cost of Flash. And so we're seeing all Flash systems actually deliver the best dollar per IOPS now. So customers that are really dialed into that, they're not so worried about the dollar per gig, and they see the value of dollar per IOPS. All Flash is a great solution. And then sitting square in the middle is the hybrid array or hard drives with Flash acceleration. And this is what's giving us the best mix of dollar per gigabyte and dollar per IOPS. And as we'll talk about, that's really becoming the new normal when it comes to storage. One thing that chart doesn't capture is latency. And so latency latency plays a role, especially when it comes to flash. So if you look at the design principles of a hybrid storage array, it's really leveraging flash media to provide a good average latency. And so this is a chart that I really like, and this is focused on databases, but I think it'll apply to other applications as well. So what we're showing is the percentage of IOPS that are delivered at a certain latency. And so if you size a hybrid array correctly, you put enough flash in there, or the architecture of the storage is doing what it's supposed to do, we will see most of our IOPS served from flash. And so we'll get that, the quote-unquote sub-millisecond latency for the majority of our IOs. However, if you have a cache miss or the data does not reside in cache, then we have to go to disk, as we do with a traditional storage system. And in that case, you're going to see a latency of maybe 8 milliseconds, sometimes longer with SATA drives. And so you can see the balance here is really getting the cache technology correct or the cache size correct so that you can get the majority of your IOs served out of cache and minimize the amount of disk latency IOs that you have to go to. But this results, overall in a good average latency. And we'll typically see a latency in the, let's say 3 to 4 millisecond range. But again, there are no IOs that are served at 3 to 4 milliseconds. They're either going to be under 1 or they're going to be 8. But from an average latency perspective, the overall hybrid solution looks pretty good in the 3 to 4 range. So what all flash storage does is it utilizes flash media, and obviously all flash media, to provide consistent, predictable, low latency. So all flash is really about getting every single one of your IOs under that 1 millisecond range. And simply put, it's about eliminating the bump. It's about eliminating that 8 millisecond bump. So if you're an organization and you have a SLO of every single IO has to be under 1 millisecond, all flash makes sense for you. And my favorite example is there's a fraud detection company, and their IOPS requirement was actually under 100. It was almost ridiculously small, but they had a service level agreement out to their customer bases of how quickly they could do the fraud detection, and so they just absolutely could not afford any 8 millisecond IOs. And as a result, even though they did not have extreme IOPS requirements, they did have an extreme latency requirement. And for them, all flash made the most sense. So again, if we look back, the hybrid array is the best mix of dollar per IOPS and dollar per gig. It gives you the speed of flash with the capacity benefits of disk, and it's really perfect for most workloads. So we see the consolidated workloads, especially where you're storing lots of data, but you do want to flash accelerate it. Hybrid arrays are a great fit. And again, this is really what's becoming the new normal. We had some analyst meetings a year ago, and and today we're still talking about hybrid arrays. Not too long in the future, this will just be a storage array. The flash piece will be so commonplace that a traditional array, a traditional all-disk array, is really going to become one of the outliers. And then for all flash arrays, it's really when you need predictable ultra-low latency, that sub-millisecond latency, or even sub-half millisecond latency, or you have an extreme IOP or throughput requirements. And so really this is for performance-driven applications. And we're going to give you some examples of those here in a bit. One of the things when we talk about flash, and again, there's the long-standing notion is that flash is really expensive, and and a lot of customers are having a hard time. Hybrid array, even though you have flash involved, actually does bring value, and it can lower your cost. So here we did an example of taking a 144 terabyte system, all sitting on 10,000 RPM SAS drives, so 240 drives in this case. And we replaced that with a system based on SATA drives, so 1 terabyte SATA drives. We only needed 168 of those to get to the capacity that we were after, and we supplemented that with 1 terabyte of flash cache. And what we saw from that is an immediate cost impact and efficiency impact. So we lowered our cost per terabyte, even with the more expensive flash media, the fact that we're buying fewer hard drives and lower cost hard drives in a SATA drive versus a SAS, we're actually able to lower our cost per terabyte. We're able to improve our cost per IOP, so lower is better, and then also draw significantly less power. You go from 240 10K drives to 168 SATA drives. That's a dramatic reduction in power. But we didn't really sacrifice anything. In fact, we got more capacity out of this configuration, 144 up to 168. We got more IOPS out of this configuration, and we had an 18% improvement in average response time. So again, you're going from everything in a SAS disk to some IOs served out of flash, some IOs that do go to SATA, but overall, we saw an improvement in our average response time. So this is kind of a simple picture just to show you the value of a hybrid array, of what injecting a little bit of flash into a big configuration, what it can do for you. As another example, we're going to look at one of our customers, which is the city of Fayetteville, which is in North Carolina. And so this customer was really trying to look at ways to lower their cost. And so they were looking at virtual desktops, so putting in a virtual desktop infrastructure. The biggest concern they had, and I think a lot of customers have when they look at VDI, especially for power users, is to make sure I'm not sacrificing performance as I look to drive this efficiency and lower my cost. So for them, it was very important to keep pace with all the 911 calls that they get, the ability to dispatch their emergency services, so police and fire. They could not afford lag or a performance impact for this very critical users. And then they're also looking at how they could reduce their backup or restore times by going from tape to disk backups. So, capacity was still important to these guys along with the performance. So what we saw from them is to deploy a hybrid FAS system. And again, as we just talked about, this allowed them to balance the cost efficiency along with the performance demands. And now they're able to have their police and fire first responders respond faster to dispatch requests, which is, again, overall improving their public safety. It really made it a workable solution for them to get this critical information out to their emergency responders faster than they were before, but also helps by cutting their restore times and saving them in the 30% in their overall storage cost. And then, a nice little side effect of this as well is reducing some of the storage space. So we didn't talk about that as much, but that certainly brings tremendous value nowadays. As we're looking to store more and more data, when you can start taking up less rack space and less storage space, that brings along the power and the cooling savings as well. And then we had a nice little quote, from the IT manager that the first responders were very impressed by the performance of their virtual desktops. In a lot of cases, I think, going to a VDI infrastructure, there's typically a lot of hesitation on the user perspective. So this was a nice endorsement of the direction that they chose to go and allowed them to, again, cost effectively achieve their goals of both performance and cost savings by going to a hybrid system using NetApp's flash pool. So now if we move on to all flash. So we talked a little bit about this, but all flash is really about leveraging this technology where it's going to make the most impact. So these are typically latency sensitive workloads where improving responsiveness of the application leads to very real gains in productivity or time to market or customer satisfaction, and then ultimately revenue. So if you have these latency sensitive or response time sensitive applications, that's where all flash makes the most sense. So these are typical transactional workloads, so online transaction processing, anything with lots and lots and lots of small I/O that's typically linked to online ordering or anything like that. We see a lot of all flash now in analytics. So customers are using this to either ingest more data or to do queries against databases a lot faster. We've seen ingest rates that we'll talk about, trying to go from hours to minutes and from minutes to seconds so that they can make better decisions. We're also seeing a lot of flash in reservations or customer service systems, virtual desktop infrastructures, as we just talked about. Hybrid arrays work very, very well in a lot of virtual desktop infrastructures, but we are seeing, the quote-unquote power users. So it's like engineering or media files or companies that have big I/O requirements per desktop. They're going to, in a lot of cases, to an all-flash environment. And then web services or technical computing. So again, anything response time sensitive sees a lot of value in all flash. And to illustrate, we'll walk through a couple of examples. So Universal Investment is one of Germany's most successful investment companies. And they came to us, they're actually a longtime NetApp customer, and they came to us with a challenge of helping improve their database performance because they're really looking to secure their competitive advantage and handle the additional data that's starting to come in so that they can make better decision makings. So this is driving their application that does a lot of their investment management and a lot of their business intelligence. So they came in and they deployed 4 of our EF flash arrays, and they used this alongside some of their existing FAS systems. But they put their production database, the key applications, again, doing the business intelligence, doing the investment management on the EF flash arrays. And some of the results they saw were a 12x improvement in response times, in their average response times. So now they're seeing every single database I/O coming in at under 1 millisecond. So a significant improvement there. They also do a lot of these deep analytical queries where they're going through a tremendous amount, the millions of database records. And in this case, they saw a 50% reduction in the time it needed to go through all those records. So doing a lot of these analytical jobs in half the time that it required before. Another great advantage that they saw was a 90% reduction in the time they needed to recreate database cache following a restart. So this isn't something that comes up from them from time to time, and the ability to, again, go from hours to minutes on repopulating that cache had a very real impact to their users using the application sitting on the database. And then finally, backup times were reduced by more than 75%. So, they really saw an across-the-board improvement in their database performance that's critical to all of their business-critical applications that run over top of it. Another example, this is a contract oil drilling company. And, so this is a company doing drills for their customers, and they were typically capturing data about that active drill about every minute. And then they send that minute, that data to their customers so they can make decisions about, do you want to keep going, do you want to stop, what do you want to do? And they came to us and they said, we want to reduce this ingest rate from 1 minute down to 1 second so that we can give our customers more data and better access to real-time analytics. So again, we turn to our EF540 storage system, and this gave them both the IOPS that they needed as well as the bandwidth they needed to get that ingest rate from a minute down to a second. So if you think, that is a tremendous reduction in ability to just ingest a lot of data and then run analytics on that data as well so that their customers can make better decisions using that up to the second drilling data and have better decision making about the active drill. So again, a great customer that used all flash to provide real value to their customers in a way they couldn't do it with a traditional system. And then finally, we had a global software developer who was looking to speed up their software build process so that help out their engineers and really have a noticeable difference in their time to market. As they go, the active code builds and doing that takes a tremendous amount of compute power, and the longer it takes, the longer you have to wait before you can go try a new version and see if what you just did worked, when you're compiling that code. So in this case, they deployed 10 of our EF systems alongside their existing FAS platform. So they were using our FAS platform for shared storage infrastructure, and they offloaded the active code builds, the compiling that was going on for their for the software onto some EF systems. So in this case, it's kind of a temporary workload. It's something that's the active code builds. It's doing all those compiling. End of the day, all the data goes back to a FAS system. But by offloading this very I/O-intensive task and this almost temporary data flow to an all-flash array, allowed them to triple the throughput of their build system. So they're doing 3 times as, doing builds in a third of the time that it took before, or being able to do, 3 times as many builds in a day. And then by offloading this I/O-intensive task from their shared storage platform, it also enabled them to double the number of code threads that they were supporting per FAS. So it helped them reduce their storage footprint, through the efficiencies of data on tap. And again, leveraging the features of data on tap, they were able to replicate this build data to their global development teams. So, we really see a company taking advantage of the full NetApp portfolio, and by, leveraging what EF does best, which is drive higher application performance that's only possible with an all-flash system and a highly optimized system, and then leverage all the capabilities of ONTAP. So storing that data very efficiently, protecting that data, and then replicating that data to additional development teams around the world. And again, doing all this non-disruptively. All right, so those are the examples I had for you today. Just talk to you a little bit about Flash, where we're seeing Flash, the impact it can have from a cost perspective, from a performance perspective, how customers are using hybrid, again, the new storage array, the new model, I believe, today, because it really gives customers the best of both worlds, speed of flash, capacity of disk, good mix of dollar per IOPS and dollar per gigabyte, and then the environments where you really see customers leveraging all flash. Where does that, driving down application responsiveness, making it faster, where can it pay real dividends for your productivity or your revenue?